What we're doing today is we're continuing on with our addition, subtraction, multiplication, and division word problems. And this one here on 7.3, 7.3.2, page 104, is where we're picking up. A snail traveled exactly 25 seconds at an average speed of 0.8 meters per minute. Which of the following is closest to the distance in meters traveled by the snail? So again, when we look at these here, so we are talking about multiplication and division. And rate times time is equal to distance. And we're wanting to know the distance, and we have a rate and time. Now the rate that they gave us is what? 0.8 per minute. And the amount of time that they gave us was what? 25 seconds. Can we just plug in 25 seconds? No, we need to know it in minutes, yes? Well, how many seconds are in 1 minute? So 25 over 60 would be our minutes. Now we could reduce it if we wanted to, or we don't have to, because we can just do what? 0.8 times 25 over 60. Which would give us so 0.333, and that's closest to what? 0.3. So the amount of distance traveled is 0.3. So we didn't use multiplication, but we had to be careful of our units. Since they gave it to us in seconds, when we plugged it in, we had to convert it over to minutes, because once we had it in minutes, then we had it in the correct units and we could solve. Any other questions on this here? Are we ready for the next one? A taxi driver traveled at an average speed of 35 miles per hour and arrived at her destination in exactly 15 minutes. Which of the following is closest to the total number of miles she traveled? So, again, rate times time is equal to, now the rate they gave us was 35. And this is in what? Miles per. And what was the time that they gave us? 15 what? Minutes. We need it in, do we need it in minutes? We need it in what? How many minutes are in an hour? So to find out how many 15 minutes is in hours, well, we can just do 15 divided by 60. Really, at this point here, we can do what? 35 times 15 over 60. And the total distance traveled is 15 minutes in an hour. Well, 15 plus 15 is 30. 30 is 60, yes? 15 minutes is a fourth of an hour. Would we agree with that? So if it was 1 hour, how far would they have gone? 35 miles, yes? So about a fourth, if we divided that by 4, we would get about 9. Because if it was close to 30 minutes, we would think about half, so about around 17, half of that. Questions on this here? Riding a bike at a constant pace for 30 seconds per third mile, how many minutes would it take to ride 4 miles? So at a constant pace of 30 seconds per third mile, how many minutes would it take to ride 4? Because 30 seconds, we're at a third of the mile, yes? Exactly. Because 60 seconds, we would be at 2/3, and at 90 seconds, we would be at a mile, yes? Well, 90 seconds is what in minutes? 1.5, yes? Well, we're wanting to go to what? 4. Well, 1 times what is 4? 4. So we can take 1.5 and multiply it by 4, which would give us 6. How many minutes would it take? 6. Now we could have kept counting up by 30 seconds, because instead of saying 60 seconds, we could have said 1 minute, and then 1.5, or 1 1/3, 1 2/3, or 1, 1.5, 2, 2.5, counting up and going by thirds. Any questions on this here? Jogging at a constant pace of 150 seconds per quarter mile, how long would it take to run 3 miles? So 150 seconds, you've gone 1/4 of a mile. 150 plus 150 would be 300 seconds would be half a mile. 450 seconds would be 3/4. And 600 seconds would be 1. Well, what is 600 seconds in minutes? The 600 divided by 60 is? So for them to go 1 mile, it takes 10 minutes, yes? So is 7.5 or 5 possible choices? Well, no. Because it took them just 10 minutes to go 1 mile. How many more miles do we need to go? 2 more. If each mile is 10, we're going a total of, so how long would it be? 30. Questions on this here? Chet rents a car for a month. It costs $260 fixed charge to rent the car for 1 month, and $8 for every 100 miles driven in it. Chet drove 3,000 miles in the rental car. What is his total bill? Well, we know the fixed cost is 260, yes? Is there any chance that it's going to be $270? Probably not, because that's only a $10 difference, and he's getting charged $8 for every 100 miles. So just going 100 miles would mean that it's going to be $268. So that's probably not it. Now we know that he's charged $8 for every what? 100 miles. How far did he drive? So he drove 3,000 miles, yes? And for every 100 of those miles, he gets charged $8, yes? All the way up to the 300, 3,000. So what can we do? We can take 3,000 and divide it by 3,000 divided by 100 is 30, because those two zeros will cancel out with those. So how many times did he get charged $8? 30 times 8 is? Well, that's not one of my answer choices. But it asks for the because it added the original price. So the correct price is 500. This one here, we had to do a few more steps to get to the answer. Any questions on this here? A small warehouse store pays for the electricity it uses. The monthly cost is a fixed charge of $200 plus $12 for every 100 units of electricity used. Last month, the store used 1,200 units of electricity. What was the total cost of electricity for the store last month? Well, what is the fixed charge? $200. So the cost for using electricity is going to be no less than what? Can't be 144 because that's less than the actual charging price that we started with. So we know that it's going to be $200 for sure. And then we have $12 for every 100 units after that, yes? So if they use just 12 or 100 units, it would be, well, our $200 plus 12, so $212, yes? Well, did they use more than 100 units? Well, yeah, they used 1,200, right? So is 214.4 a possible answer choice? Well, no, because if we just used 100, well, it's 212 for $2 short of that. No, we have another 1,100 units that are used. So that's probably not going to be it. Now, there are several different ways we can go about doing this. We can start off with saying, well, 100 units would be $12. 200 units would be 24. If I add again, 300 units would be 36. 400 would be 48. 500 would be 60. 600 would be 72. 700 would be 84. 800 would be 96. 900 would be 108. 1,000 would be 120. 1,100 would be 132, and 1,200 would be $144. So the amount that they get charged for the 1,200 units is $144. That works too. We can do 1,200 divided by 100. Because 12 times 12 would be 144 plus 200 is. Any one of those three ways will get you there. Because the correct answer is 344. It's figuring out what is the best way that y'all can see it. Because if you can see it by doing the 1,200 divided by 100, multiplying it by the cost, and getting there. Do that. If using equation works best, do that. If writing it out like we did works, do that. Pick which one that works best for you. This one here is not in your workbooks. But this here, if 20 toy trucks cost $25, what is the cost of one truck? So 20 toy trucks cost $25. What's the cost of one? Well, as we can take 25 and divide it by 20, part over whole, and get there. Or really, we're saying that 20 times the cost of the truck is equal to $25. To find out what one is, we can divide both by 20. 25 divided by 20. Because we could talk about this in proportions or in different ways there. Now, if the cost of the toy trucks was $1, 20 of them would be how much? $20, yes? So we know it's going to be greater than 1. So that means A is probably not going to be it. Now, we could have worked it out that way and said 20 times 1.05, does it give me $25? If it does, then that's the correct answer. If it doesn't, we could try 1.25. Then this here would. If it didn't, then we can move on to 1.5 or 1.6. So sometimes using the answers in the numbers given can get us to the right answer. 25 divided by 20 is equal to 1.5. So the cost of the truck is, or 1.25. Bud needs to grow 700 roses for the local farm market. If Bud knows that the seeds he is planting will yield on average 1.25 roses per square foot, Bud needs to plant how many square feet of seeds? How many does he need? 700. And on average, 1.25 roses per square foot. So what are we going to do? Right. Yes. Yes. I mean, that's 100% that would work, because that's one way to reason through it without actually knowing the exact calculations. Another way we can look at it is we need to know what? Square feet, yes? Now we're given 700 roses. And this is roses per square foot. So 125 is roses per square foot, yes? And we have 700 roses. If we wanted to use units to get that to cancel out, well, I need the roses and roses to cancel out, yes? Well, we would need 1 over roses, so it would be 1.25 divided by 700, which should give us our 560, I believe. No, it's the other way around. 700 divided by 1.25. It Actually, let's give us the 560. But I do like, Ian, your way of looking at it better, because that is a better way to look at it. Because if we know it's 1 rows per square foot, we'll need 700. Since it's a little bit more than that, we need less acreage. So it brings us down. Because even just knowing that, remembering that part, that if it's 1-to-1, then we would need 700. It's more than that. We get more from it. So we can take those two out. And we could go from there. Any other questions on this here? A cyclist traveled at an average speed of 18 miles per hour and finished his bike ride in exactly 4 minutes. Which of the following is the closest number of miles traveled? Well, rate times time is equal to distance. 18 miles per hour, finished her bike ride in exactly 4 minutes. Closest number of miles traveled. Well, our rate is 18 miles per hour, yes? Well, we can't do it in minutes. We need it in hours, yes? How many minutes are in an hour? Would 1.2 be rounded down or up? What do we think? Down. Because it has to be what to round up? 5 or greater. And that's it. So here it's just referencing back to our rate times time is equal to distance. Any questions on this here? A vintage baseball card was purchased 6 years ago for $1,860. The card is currently valued at $2,400. What was the card's average increase per year? So how many years have passed? And it's asking for the card's average. So how much did it increase? Because we can subtract the 2, 0, 3, 10. So it increased a total of $540, yes? And we're wanting to know what, how much it increased. $90. Because we know that it's going to increase whatever that amount is across the 6 years, yes? So we could do 6 times 90 and add it to our 1860 and see, does it give us 240? If it does, awesome. If it doesn't, that's fine. We can do 6 times 270, 0, 2, carry the 4, 6, 12. Well, that alone is 1620. That's not going to work. Because essentially we could add that increment into it as it was the increase and see if that does get us to our final answer. But the rest of them are way too big. Let's look at the next one. Anna bought her motorcycle 8 years ago for $5,320. It is now worth $2,840. What is the average decrease in value of the motorcycle per year? Doing absolutely no calculations, because how much time has passed between when she bought it and now? Tell me at least one number, one of the answer choices that does not work at all. $1,240, yes? Let's just say 4 years. 1, 2, 4, 0. 4 years has passed. 0, 6, carry the 1, 8, 9. That'd be $4,960. Wait a minute, she started at. So even if we took this the full 8 years, 0, 2, carry the 3, 16, 8. Let's just subtract what she started with. 0, 0, 6. That means her motorcycle would be technically worth negative $4,600. Yeah, that ain't it. Because realistically, we know no matter how long you keep a motorcycle or any type of vehicle, its actual value will never hit 0. Because you can still sell it for scrap. Metal's still going to hold its value no matter what you do with it. So that probably isn't it. Well, we could keep doing that, multiply the 665 by 8 and subtract it from there, see if we get there 620 doing the same thing. Or we can take this here and subtract $2,840. $2,480. Because that's the amount of time passed. It's 310. Now, the last two, it worked out that they were both A and F, first choice. It's not always going to work out that way, but I think y'all have noticed that whenever they give the answer choices, it's always from smallest to biggest. They always go in that order. So one of the methods that may work, it's not something that's guaranteed to work, but if you're trying to plug numbers in, I can write, come on. You can normally try to guess in the middle, because if that number produces something that's too small, the bottom two are going to be it. If it produces something too big, we can go with the top two because they're going to be smaller. Question number 5. Cole wants to work enough hours to buy a necklace that costs $370. He earns $11.25 per hour, and he has already worked 24 hours. What is the minimum number of whole hours that Cole must work in order to afford the necklace? Well, how many hours has he worked already? So we're trying to get to 370, yes? Well, we can say 11.25 times 24. Because we can multiply that, 0, carry the 2, 8, 9, 10, 0, carry the 1, 4, 5, 0, 0, carry the 1, 5, 2, 2, 0, 0, 1, 4, 5, 6, 7. So far he's earned $271. Yes? 270, thank you. That makes more sense. Yep. 270. He needed so how much does he have left to earn? He's earned $100, yes? How much does he earn per hour? So if he worked exactly 10 hours, what would that be? What's 1125 times 10? We're just moving the decimal 1 unit to the right. 112. Does he need $112? No. So that means D and E are out. It could be 9, because 11.25 times 9, 5, carry the 4, 18, 2, carry the 2, 9, 10, 11, 1, carry the 1, 9. That would be it, because if we drop another hour past 9 down to 8, that's going to be under $100, yes? So correct answer is C. Question number 6. Jose wants to work enough hours to make at least $93 this week before taxes are deducted. He has a job that pays $7.25 per hour and has already worked 7 hours. If Jose can only work in full hour increments, how many more full hours must he work to meet this weekly goal? Let's make it simpler than the last one. What's $93 divided by 7.25? What is $93 divided by 7.25? 8. Which said whole hour, so we've got to go up. Yes? Now, how do we know that we have to round up? Yeah, we have to work whole hours. Now, for mathematically, because it is 8.8 is greater than 0.5, we would round up. But because of whole hours, well, if it was 0.2, well, we still need to work the entire hour to earn that wage. So it has to be 13. Even if it was 0.01, we'd still have to round it up. How many has he worked already? 13 minus 7 is? Could we have done the last one the exact same way? Yeah. All right. So I believe the next part is 7.4.1, the practice set. Yes?